All right, for example 5, I want you to try to go ahead and make the sketch of this and come up with your primary and secondary equation, and then go ahead and substitute in to find your primary equation in one variable. Go ahead and pause the video and come on back when you think you've done that to check your work. Okay, welcome back. So here we have our square and it's x by x. So the area is just going to be x squared here, and the perimeter is going to be 4x. Now we know the area of a circle is pi r squared and the perimeter is 2 pi r. So our actual primary equation is going to be area is x squared plus pi r squared. And then using our secondary equation, we know the radius here has to be 4 minus 4x over 2 pi, and we reduce that down and then factor out the 2, and then we substitute that back in for our radius because we don't want an x and an r. So here is your primary equation in terms of x. Go ahead now and find the derivative of this and the critical numbers. And you can pause the video and come on back to check your work. Alright, welcome back. So you should have been able to find your derivative here, set it equal to 0, and it turns out your critical number is about 0.56. Okay, next I want you to find your feasible domain, and when you think about it, you have to decide, where are you going to put your wire? Are you going to use it for all for your square or all for your circle? And then once you find your domain, you need to test your endpoints and then also test your critical number to see which one will give you the maximum total area. So go ahead and pause the video and then come on back with your final answer. Alright, welcome back. Now your feasible domain had to go from 0 to 1 for x. Because if we had 4 feet of wire to make a square, right, you could use all of it on the square, meaning you would have 4 divided by 4, meaning 1, 1, 1, and 1. So x could have equaled 1. Or you could have used none of the wire on the square and used it all on your circle. Okay, in that case, x would have been 0. Now you do have to test your endpoints, a of 0, a of 0.56, and a of 1. And when you substitute this back into your primary equation right here, okay, you would find that area is 1.27 and 0.56 and 1. And so the maximum has to be right here at x equals 0. And so the way this is going to make the maximum area is that all 4 feet is going to be used on the circle. And that is finding an endpoint maximum.